Imagine this: a new manufacturing plant is commissioned and every little thing looks absolutely perfect on paper. But then, here's the thing: on the very first day of full operation, the lights begin to flicker. Yes, the motors stall and protective devices begin tripping. So the big question is, what happened? And this question will be answered by the engineers. Yes, you watching this video, you have to answer this question. So what happened? The reality is this: the engineers underestimated the system loading and voltage profile. As simple as that. Now, this is the reason load flow analysis is one of the most important studies in power system engineering. Hello and welcome back. My name is Jesse from JP Smart Solutions Ltd, where we help engineers and organizations to design, to analyze, to optimize, and to protect their power systems using ETAP software. So, as earlier stated, in today's video, I'll be introducing you to load flow analysis in power systems. So, just a brief overview of what we are going to be covering in today's session. Firstly, we are going to be talking about what load flow analysis really means. We are going to be explaining the fundamental concept of load flow analysis, what it is all about, and we are going to move on to why it is critical for safe and reliable system design. So, why do we carry out this load flow analysis? Why is it important for us to carry out this load flow analysis on our power system? How does it ensure a safe and reliable system design? And then we are going to be giving practical insights on how ETAP performs load flow simulations. So we are going to switch to ETAP software and carry out a load flow analysis and explain the results obtained. This is a summary of what we are going to be doing in this video. And remember, this is just an introduction. The detailed step-by-step training is part of our ETAP training class. And you can actually enroll using the link below this video. But let's dive right into the video. Now, the first thing, what does load flow analysis really mean? What is load flow analysis? Now, it is important to note that a load flow analysis is also known as a power flow analysis. So, load flow analysis and power flow analysis, they are one and the same thing. So, a load flow analysis or a power flow analysis is a systematic mathematical approach which is used in the determination of various operating bus voltages, their phase angles, active and reactive power flow through different branches, generators, and loads under steady state conditions. So primarily, we are focused on parameters such as the operating bus voltages, their phase angles, the active power flow, and the reactive power flow. This does not mean that a load flow analysis is limited to these parameters. So, yes, I know this looks pretty long, and for people not in the engineering sector or precisely in the power system engineering sector, you may struggle to get this. So, let me explain in simple terms. Simply put, A load flow analysis or a power flow analysis is carried out or it is performed to verify, to determine the existing operating state of a power system, to know how our equipment in the power system are operating. We carry out a load flow analysis. So when we say load flow analysis or power flow analysis, now many engineers think it is just about calculating the voltage magnitude at each bus bar. But in reality, it is far more than that. Yes, much more. Now, load flow analysis answers critical questions such as, will the system be able to supply all the connected loads, or would there be need for an improvement to the system? Now, it answers questions like, are the voltages within acceptable limits across the entire network? It answers questions like, are any lines or transformers overloaded? It answers questions like, what are the real and reactive power flow through each branch? Let me share a story. One of our clients was operating a large commercial complex, and they started experiencing frequent voltage dips whenever their chillers kicked in. Now, at first, you will suspect the utility, just like they did. They suspected there was a problem from the utility. But then we were consulted, and after we modeled the system using ETAP software, we carried out a load flow study, also known as a load flow analysis, and the problem was crystal clear. Now, can you guess the problem? The transformer feeding that part of the building was already overloaded at 110% of its rated capacity. That was the problem, transformer overload. Now, the solution was simple. Redistribute the loads and plan for an upgrade. However, without load flow analysis, they would have continued guessing or continued assuming that the problem was from the utility. And the problem with this is you are wasting both time and money. Now, moving on to the next section, why load flow analysis is critical. Why is load flow analysis critical? Why do we need to carry out load flow analysis? Now, it is important to emphasize that load flow analysis is the foundation of all power system studies. Load flow analysis is the foundation of all power system studies. Why? It is because almost every other study depends on it. I usually refer to load flow analysis as the mother of all power system engineering studies. And as I said, almost every other study depends on it. It is the first study to be carried out which will validate a project model, and it is also the last study to be performed in order to validate every other power system study. For example, short circuit analysis requires the operating condition from a load flow analysis. Protection coordination is influenced by load flow results. Optimization studies begin with load flow studies. You must carry out a load flow study to determine what is the problem with this system. Then and only then can you carry out an optimization study. You can determine an optimization approach to use on the power system network. So load flow analysis is actually the foundation of all power system studies. Most importantly, load flow analysis ensures that your system is both safe and efficient. It ensures that your system is both safe and efficient. Very important. Now, ignoring load flow analysis may lead to voltage instability. Ignoring this may lead to voltage instability. And what can happen when we have voltage instability? Sensitive equipment may fail or misoperate if the voltage is too low. Ignoring load flow analysis may lead to overloading of equipment. Overloading of equipment such as your cables and transformers, when they run hot, they lead to fire hazards. Just as the first case I explained to you, where their transformer was overloaded. The reason was they ignored load flow analysis. So I'm sure after this you won't make the same mistake. Also, ignoring load flow analysis may lead to economic losses because inefficient systems waste energy and increase operational costs. Simply put, in short, in very simple terms, if you do not run a load flow, you are actually designing blindly. You are designing blindly. So let me give you a preview of ETAP software in action. I will switch over to ETAP software now. All right. So over here we have the utility source power grid connected to an 11 kV bus bar. And on this bus bar we have 4 transformers, T1, T2, T3, and T4, each rated 12 MVA, stepping down this voltage of 11 kV to 0.415 kV. And over here we have cables transmitting this voltage, this power, over to bus 6 where we have our load connected. Similarly, we have cables on this end of the transformer. We have the load over here. The same thing over here, cable and load, cable and load. And lastly, we have the bus couplers or the tie breakers over here linking each of the bus bars together. So the aim is to carry out a power flow analysis on this system. This is just a simple network, and with just a click, ETAP software can run this load flow analysis for us. Yes, it's that easy when you know what you are doing. Very much easy. So just a single click and we already have our load flow analysis. ETAP software further even gives us the chance to customize and have our animation showing us detailed movement of power in the system. So what can we see just looking at this? The first thing we see is this guy in percentage. This guy in percentage is the operating bus voltage of the system. So over here we can see that on the utility bus, which is the swing bus, we have 100% voltage. But by the time we are getting to the load, we are having 89.96% voltage. We are having 66.47% voltage. Over here, we are having 92.12% voltage. We are having 85.03% voltage. Now, we can change this from percentage. Let's see it in actual kilovolts. So we say the bus bar here is rated 11 kV, and our load flow analysis is telling us that this is operating at 11 kV. Good and fine. We said this bus bar is rated 0.415 kV, and our load flow analysis is telling us that this bus bar is operating at 0.393 kV, which is a problem. This other bus bar over here is rated 0.415 kV, but our load flow analysis is telling us that it is operating at 0.276 kV, which is also a problem. So we can see the voltage magnitudes at each bus bar using load flow analysis on ETAP software. But it doesn't stop there. We can also see the active power flow and the reactive power flow in each branch of the system. It still shows us the direction of the power flow using these arrows. You can see power is flowing from the grid down to the load. The red arrow indicates the flow of the reactive power, while the blue arrow indicates the flow of the active power. So we can also see the loading percentages of cables and transformers. Now, looking at this, we can see this bus bar is black, this bus bar over here is pink, this bus bar over here is red, all the cables are red. You can zoom in for a better view. All the cables are red. This transformer over here is red, while this guy over here is black. So, simply put, the equipment that are still colored black are healthy. They are operating in a healthy condition, while the equipment that are colored red are operating in a critical condition. The equipment that are colored pink are operating in a marginal condition. Now, this visual feedback is powerful because an engineer can immediately spot trouble areas. Instantly, just by looking at the system, I can tell that, okay, we have a problem with this cable, we have a problem with this transformer, we have a problem with this bus bar, we have a problem with this. So we can now identify that, okay, what is the problem? We can check the problem from ETAP software. ETAP software will give us the precise problem. Is the cable overloaded? At what percentage is the cable overloaded? Can we prefer an optimal size of cable to ensure that the cable is no longer overloaded? What should be the optimal size of cable to use? What should be the optimal size of transformer to use to ensure that the transformer is not overloaded? Now, of course, this is just a quick glimpse of ETAP software. In our professional training, we cover different load flow analysis methods such as the Newton-Raphson, the adaptive Newton-Raphson, the fast decoupled, and the likes. We also cover how to impute realistic load models, and also ETAP has this feature that can allow you to generate a detailed and comprehensive output report. So we are going to be teaching you how to generate that and how to interpret the results in details, because it is one thing to run the analysis, it is another thing to know what the analysis is talking about, because without understanding the analysis results, you will be preferring the wrong solutions to the wrong problems. But even from this small preview, you can see why ETAP is trusted worldwide for load flow analysis. Now, let me give you one last story. A power utility once connected a new residential estate without performing any load flow study. Such a big risk. Now, at first, everything seemed fine. And do you know why everything usually seems fine? This is the problem with design engineers. When you design a system, you will not be aware when the system begins to fail, unless you are working for that particular industry. Because electrical problems do not happen instantly, they happen over time. It may happen in the next 2 months, 3 months, or even 6 months. And then you feel as the design engineer that, oh, when I designed this, it was working, so it is not my problem. But if we take a critical look at it, some aspects of design engineering were neglected. So, back to the story. They connected a new residential estate without carrying out a load flow analysis. And at first, everything seemed perfect. But 6 months later, when occupancy increased, that is, the load profile of the system increased, complaints started pouring in. What are the complaints? Low voltage, dim lights, and even damaged appliances, because of course voltages of this magnitude can damage the appliances in this load. So what happened? When they finally agreed to conduct a power flow analysis, it was clear that the distribution transformer was undersized for the actual demand, such as we have over here. Now, this is the problem with such an encounter. The cost of replacing it after this was 3 times higher than if they had designed correctly from the beginning. This is the reality. Load flow analysis is not optional, it is essential because it saves lives, equipment, and money. Money is very important to save. Yes. So load flow analysis is extremely essential. Now, in conclusion, all right, just a basic recap. Load flow analysis tells you if your system can supply the demand safely and efficient. Load flow analysis is the foundation for almost every other study in power systems. And ETAP software makes this process fast, reliable, and compliant with global standards. Now, if you found this helpful and you want to go deeper, I invite you to join our ETAP professional training at JP Smart Solutions Ltd. Now, in this training, we do not just talk theory, we give you real hands-on exercises, case studies, and detailed workflows to help you become proficient in ETAP, from an absolute beginner to a professional or a specialist in power system design, analysis, optimization, and protection. You can click the link in the description to enroll, or you can send us an email using this, contact us via WhatsApp using this number, or you can better still call us using this number, and we'll respond to you as quick as possible. Now, do not guess your system performance. Simulate it, validate it, and design it with confidence. Thank you so much for watching, and I'll see you in the next video.